Dear friends, here we are with the Microsoft Azure. Let's go with the introduction first. And as you know, the Windows Azure is a Microsoft's application platform for the cloud computing. Windows Azure can be used to build a web application that runs and stores its data in Microsoft data centers. It can connect on-premises applications with each other or to map between different set of identity information. So this was just a little bit of information about what the Azure is in a nutshell. Okay, let's walk through the agenda, what we are going to discuss and what we are expecting and what we are going to present today. Here is the agenda. First, the Azure introduction, Azure web role, publishing to the cloud, Azure administration, Azure storage, Azure worker role, SQL Azure, and in the end we'll go with the Windows Azure diagnostic services. Okay. That was nothing. Okay. Then we go to the slide 4, Azure introduction. Azure introduction. Microsoft's application platform for cloud computing helps to build web application and use Microsoft's data center, creation of cloud VPN, and to be used for data management. Okay, let me explain what Microsoft's application platform for cloud computing, that is Azure, what it is. Here is the overview in the picture how Azure is. You can see the internet application, the Windows Azure, the data. These are businesses and these are consumers. Now, what we know already is the goal of Windows Azure, that is what it is presented over here. It's a part of the large Windows Azure platform. Windows Azure is a foundation for running application and storing data in the cloud. That's how it is illustrated in the figure. Rather than providing software that Microsoft customers can install and run themselves on their own computers, Windows Azure today is a service. Consumers use it to run application and store data on internet accessible machines owned by Microsoft. Those applications might provide services to business, to consumer, or both. Here are some examples of the kinds of application that can be built on Windows Azure. Let's say an independent software vendor could create an application that targets business users, an approach that often referred to as a software as a service. Windows Azure was designed in part to support Microsoft's own SaaS application, and you'd like to surprised by the SaaS. It's nothing, it's software as a service. So the independent software vendor can also use it as a foundation for a variety of business oriented cloud software. Let's go further. What it is? It is an effort to see cloud as desktop, as scalable application development, more effective and trusted way for web application, providing data centers from Microsoft's data center. So you see, now you're no more bounded with your desktop. You can just have a net PC which has just a simple functionality with which you can connect to the internet and you can run all your applications we are connecting to the cloud. And what's the cloud? It's nothing, it's the internet. That's it. Now let's go further. Here is the Azure overview. It's a big picture. Of course, you can see the Windows Azure, SQL Azure, Windows Azure platform with App Fabric, and of course, you have a lot of developer tools. Developer Fabric for Windows Azure, software development kits, tools for Visual Studio. So, you see in the Windows Azure, you have facilities with which you can compute storage management. With SQL Azure, you have relational database sync services and management, and with the App Fabric you have service bus, access control service and management. Of course, it's a lot of things all in one slide, but I will walk you through each and every stuff and we'll see what it is and we'll try to understand how it goes. As I told you earlier also, that Microsoft Azure can be used to support applications and data in a web or in a cloud. Now, to support cloud application and data, Windows Azure has 5 components which are shown here: Connect, Compute, Storage, CDN and Fabric Control. What does it mean by connect? Connect allows creating IP level connections between on-premises computer and Windows Azure application. Compute. The compute runs applications in the cloud. Those applications largely see a Windows Server environment, although the Windows Azure programming model is not exactly the same as the on-premises Windows Server model. Then we come to storage. Storage stores binary and structured data in the cloud. Then we have Fabric Control. Fabric Control deploys, manages and monitors application. The Fabric Control also handles updates to system software throughout the platform. And we have CDN. What does CDN mean? It's a content delivery network which speeds up global access to binary data in Windows Azure storage by maintaining cached copies of the data around the world. So you have a cached copy, you don't need to bother about going to the actual server. They have been distributed at different places. So that's how it, I believe you might have experienced it with the when you browse something and you have something stored on your cache data, you retrieve it very quickly. I believe the Microsoft also used the same policy and they gave it as a feature. So cache is no more a bug, it's a feature. And here you can see some nice diagrams, the application and data. Here you connect, then you compute, you store, and then with the CDN you go out. Okay, let's go further. Here are few terminologies which I will use during the presentation. IaaS, what it is? It's infrastructure as a service. PaaS, PaaS, platform as a service. SaaS, software as a service. So you see all the things are as a service. So whole cloud is not an application, it's a service. You can subscribe for it, unsubscribe for it, you can use it whatever manner you want. Okay, let's go further with comparison of IaaS, PaaS, SaaS and the traditional IT. As you see in the heading, I say PaaS as Azure. Why it is? We see the traditional IT built with applications, data, runtime, security clustering, operating system in the core, virtualization, servers, storage, and networking. Thus, what all you have to manage when you have traditional IT. If we go one step further, then we have IaaS, where you manage the operating system, security, clustering, runtime, data, and applications, and the infrastructure are all managed by some other vendors. So you subscribe for the infrastructure. So the virtualization, servers, storage, and networking are all by a different person. That's no more your headache. So half of your work has been already decreased if you use infrastructure as a service. Now then comes PaaS. That's where the Azure fits. And over here, you just have to manage the applications and data, the runtime, security, clustering, even the OS, virtualization, servers, storages, and networking, all managed by a different vendor, or you subscribe. It's just a service. And here we see all things managed by a vendor. That's a software as a service. So Azure fits best at PaaS. That's where you just need to manage the application and data. Okay, so now we know what Azure is in a small words. It's PaaS, and what a PaaS is. It is platform as a service. So now we go further and go to the Azure roles. Windows Azure Compute can run many different kind of applications. Whether an application does, however, it must be implemented as one or more roles. Windows Azure then typically runs multiple instances of each role, using built-in load balancing to spread requests across them. That's how it has been shown in this picture. You see the instances for the web role, instances for the worker role, and virtual machine role instances, and all are connected with the same compute, connect, storage, CDN, and fabric control. So it's all mapped over here with the HTTP and HTTPS or TCP, the traffic. Now we go further and let's analyze what Azure storage is. Okay, before proceeding to the Azure storage, I would like to go back to the previous slide. That's Azure roles, and let's explain it in a more detail. I think that will help a lot when we go further with the presentation. Now look at the web role. You can see IaaS. I think it should be something very familiar to you. Now what a web role is, and what does it mean for you? A web role intended primarily to make it easier to create web-based application. Each web role instance has Internet Information Services, that's IaaS, version 7 pre-configured inside it. So creating application using ASP.NET, Windows Communication Foundation, or other web technologies is straightforward. Of course, you have all the subscription for IaaS. So you create and you publish it over the cloud. Developers can also create applications in native code using the .NET framework. Using the .NET framework is not really required. Of course, they can use it, but it's not really required. This means that they can install and run non-Microsoft technologies as well, including PHP and Java. So now you can see you have a method where you can use a Microsoft technology or a non-Microsoft technology or a very common web publishing or the web designing or web tools creation stuff, that's PHP. Now go further with the worker roles. Worker roles designed to run a variety of Windows based code. The biggest difference between a web role and a worker role is that worker role does not have IIS configured inside them, and so the code they run is not hosted by IIS. A worker role might run a simulation, for example, or handle video processing or do nearly anything else. It's common for an application to interact with users through a web role, then hand tasks off to a worker role for processing. Once again, a developer is free to use the .NET framework or other software that runs on Windows, including non-Microsoft technologies. Then we go with the VM roles, that's the virtual machine roles. Virtual machine roles, each of which runs a user provided Microsoft Windows Server 2008 image. Yeah, it could be Microsoft image release 2. Among other things, a VM role can something be useful in moving an on-premises Windows Server application to Windows Azure. And after all this, you can see a load balancer, which by its name is very clear. It balances the load over the cloud. So I don't think it needs any kind of explanation for it. So this was all about the roles defined by Azure. Now, how it works. To submit an application to Windows Azure, a developer can use the Windows Azure portal. Along with the application, he submits the configuration information that tells the platform how many instances of each roles to run. The Windows Azure Fabric controller that we'll discuss later, but for the time being you can just say it as a name. So the Windows Azure Fabric controller then creates a virtual machine for each instance, running the code for the appropriate role in that virtual machine. As this picture shows, that the request from the application's user over here can be made using protocols such as HTTP, HTTPS, or TCP. However, these requests arrive, they are load balanced across all instances of a role. Because the load balancer doesn't allow, here it is, see the load balancer. So, because the load balancer doesn't allow creating an affinity with a particular role instance, so there is no support for sticky sessions, and there is no way to guarantee that multiple requests from the same server, same user will be sent to the same instance of a role. So what does it mean? This implies that Windows Azure role instances should not maintain their state themselves between requests. Instead, any client specific state should be written to Windows Azure storage stored in SQL Azure. That is another component of the Windows Azure platform. That's what we had seen in the agenda, or maintained externally in some other way. A developer can use any combination of web role instances, worker role instances, and virtual machine role instances to create a Windows Azure application. If the application's load increases, he can use the Windows Azure portal to request more instances for any of the roles in his application. If the load decreases, he can reduce the numbers of running instances as well. Windows Azure also exposes an API that lets all of these things to be done programmatically. Changing the number of running instances doesn't require manual intervention, but the platform doesn't automatically scale applications based on their load. Now, to create Windows Azure applications, a developer uses the same language and tool as for any Windows application. He or she might write a web role using ASP.NET and Visual Basic, for example, or use WCF and C Sharp. Similarly, he or she might create a worker role in one of these .NET languages, work directly in C++ without the .NET framework, or he or she can use a Java. And while Windows Azure provides add-ins for Visual Studio, using this development environment is not required. A developer who has installed PHP, for example, might choose to use another tool to write application. To allow monitoring and debugging Windows Azure application, each instance can call a logging API that writes information to a common application-wide log. A developer can also configure the system to collect performance counters for an application, which measures its CPU usage, store cache, crash dump if it fails, and more. This information is kept in Windows Azure storage, and a developer is free to write code to examine it. For example, if a worker role instance crashes 3 times within an hour, it's a lot. But if it crashes really 3 times an hour, custom code might send an email to applications administrator. So the ability to execute code is a fundamental part of the cloud platform, but it's not enough. Application also need persistent storage, and which we'll see over here, the Azure storage. Here we see the basic diagram for the Azure storage for the blobs, tables, queues, and all. So this we'll discuss later in the presentation, because we have one chapter for that also. So it's just few things you can see in the diagram, so just remember it, and we'll see it when we move to the storage portion. We have the SQL Azure. Of course, you're very familiar with the SQL. Here we have different layers: the client layer, the service layer, the platform layer, and the infrastructure layer. All will be explained when we reach to the SQL Azure section. Now we have the application fabric, or the app fabric, which connects all on-premises and cloud all together and makes all the communication which is required for the application to run and make the client and the vendor happy. Here we see the Microsoft data center, of which I was talking earlier in the presentation. They have 6 data centers, 2 in Asia, 2 in Europe, and 2 in America. So geographically they have 6 data centers across 3 continents, which is a good policy to support the data to be stored, and they can promise of a persistent data storage. Okay, so with this we are finished with the Azure introduction, and now we have the Azure web role. We go into it. First think first the configuration and what it is. Create a basic Windows Azure web role ASP.NET project. Create and configure ASP.NET web application as a relying party in ACS version 2 management portal. Configure Windows Azure web role ASP.NET project for federation with ACS version 2. Make modifications related to specifically to Azure ACS version 2. Then deploy your solutions to Windows Azure and test your solution. That's all. So basically what you see is the most important stuff over here is the point 2. Create and configure ASP.NET web application as a relying party in ACS version 2 management portal. You know, there is a management portal about which I was talking earlier in the presentation, which can manage all the roles, the worker roles, we had 3 roles. So here it is, the web role, the worker role, and the VM role. So this is this management portal. The ACS management portal is the one which manages everything. So you know how the configuration is now. We go further and see what is there in the web role. We have endpoints. The web role endpoint configuration is what we were discussing over here. Now I attached a screenshot from a service project underscore web role, a small test project which I created, and here you can see what you need to specify in the endpoints. You can specify the HTTP name as HTTP in, HTTPS the secure one, the HTTPS in. Of course you can say you have to provide the ports. With the HTTP is a very famous port 80. With the HTTPS the port will be 443, and you can provide SSL name, and you have internal endpoints with internal HTTP in. That's the configuration for the endpoint. Now we go on to security and login. Before going into the security and logging, I would like to look into the endpoints a little bit more detailed than what we discussed earlier. We know that the platform from the Windows Azure provides a setting page, that's what it is, and where you can configure the endpoints, that's what I discussed also. And it creates a definition file, the service definition.csdef, in which everything will be written as HTML code kind of stuff. Then you can specify the worker role. Actually you can specify some worker role endpoint configuration also, and this also goes in a service definition, but that you can see only if you create a Azure project. So I think that's enough for the endpoint configuration of Windows Azure project. So we move on to Azure web role, security and logging. What it is: a service layer security in place. It's a fusion of on-premises and cloud security, of course, because the same Azure is a fusion of on-premises and the cloud. So the security should be in the same manner. The listener for app logging of for all the applications logging and hooks up the standard Windows as a diagnostic listener and a robust logging strategy. Ideally, any server application and basically any web application, including those running under Windows Azure, has a logging and tracing strategy designed in from the beginning. The logging information should be robust enough to describe nearly everything that's happening with and within each component. However, just as those print statements are a lot of output for the logging, so a well designed logging and tracing thus includes ways of adjusting the type and volume of logging from any component. Of course, we don't need to log each and every milliseconds, but whatever is happening and can be dangerous or a threat should be logged. A well designed logging and tracing thus includes ways of adjusting the type and volume of logging from any component. This allows operational staff and developers to focus on a particular misbehaving component. It's not just an intrusion the from an alien world, but from within the component also, and perhaps even on a particular machine to get much more information and what exactly happening inside it without generating a lot of noise in the log that can be distracting and perhaps slow down the application significantly. Of course, when you work with servers, you have to be very careful with the slowdown of the applications. You might have experienced in your profile or your work that most of the time when you face a issue, it's the server which is running under a very heavy load, and that slows down all the applications. So furthermore, because server applications are commonly distributed applications, so information must be collected and aggregated from multiple machines, perhaps in different application roles, to get a full picture of what was going on when a particular problem occurred. So a way to identify a transaction thread through the machine is important, allowing the aggregation after the fact. The logging available in Windows Azure has matured through the community technology preview releases. The earlier logging was not much more sophisticated than a print statement captured as text in Windows Azure table storage. Starting with the PTC 09 release, Windows Azure began to offer a much more full-featured logging and tracing infrastructure based on the event tracing for Windows ETW framework. This ETW framework is supported in ASP.NET through classes in the System Diagnostics namespace, the Microsoft.Windows.Azure.Diagnostics namespace, which inherits from and extends standard System Diagnostics classes, enables the use of System Diagnostics as a logging framework in the Windows Azure environment. ETW or event trigger for event tracing for Windows framework provides a module in which code logs to one or more trace sources. The level of logging allowed through each source is controlled by the source switch. Sources are in turn connected to one or more consumers, which persist the logging information in different ways. Windows Azure provides a standard consumer or listener to persist the logging information you generate either to Windows Azure table storage or the blob storage. You also can write your own consumer if you want to do something different with the event data or use an off the shelf consumer, although some might have to be modified to work in the Windows Azure environment. The ETW framework associates a trace event type with each event. There are a lot of the trace event types, such as critical, error, warning, information, verbose, start, stop, suspend, resume, and transfer. The critical means a fatal error or application has been crashed. Error is a recoverable error. A warning, that is a non-critical problem, may be an indication of more serious problems to come. So a warning is not to be ignored, as that's our hobby of the programmers. Information, just an information message. Verbose is a debugging trace which you put in all our modules to see where we are and how much time did one of the module took. Start says the starting of a logical operation. Stop says the stopping of the logical operation. Suspend is the suspension of the logical operation. Resume is resuming a logical operation. And so as the transfer to a new activity. So further on we go to the next slide, and now we talked enough of the security and logging. Now we go on to the load balancing. External communication with virtual machines occurs through endpoints that we can see. These endpoints are used for different purposes such as load balance traffic or for direct virtual machine connectivity like RDP or SSH. You define endpoints as you had seen in the one of the slide. Yeah, here you define the endpoints. Okay, go back to load balancing. You define endpoints that are associated to specific ports and are assigned a specific communication protocol. An endpoint can be assigned a protocol of TCP or UDP, that also you can see here. It can be HTTP, HTTPS, but of course it can be TCP also. Each endpoint defined for a virtual machine is assigned a public and private port of communication. A private port is defined for setting up communication rules on the virtual machine, and the public port is used by Windows Azure to communicate with the virtual machine for external sources. If you configure it, Windows Azure will provide round-robin load balancing of network traffic to publicly defined ports of a cloud service. When your cloud service contains instances of web roles or worker roles, you enable this load balancing by setting the number of instances running in the service to greater than 2, or by defining a public endpoint in the service definition. For virtual machines, you can set up load balancing by creating new virtual machines like this. Your virtual machine 1, 2, 3, and you have a Azure load balancer, all runs at port 80, that's HTTP. So a load balancing endpoint is a specific TCP or UDP endpoints that is used by all virtual machines contained in a cloud service, and there are few steps that includes a task that has been shown in this picture. You create a first virtual machine, add an endpoint to the first virtual machine, add virtual machine to the cloud service, then you set up a load balancing of the virtual machine, and then you define the load balancing probes. So with this you complete with the how you do the load balancing. If you have to go further in that, you can refer to Microsoft's MSDN website, and you can just look for the load balancing for Azure Webro. They can explain with screenshots and with a great help. So enough of load balancing now. We move further, and the next item in our agenda is publishing into the cloud. So what it is, first we need to create an account at windowsazure.com. I have a MSDN subscription, so I already have an account. So if you don't have, you create an account and then you have a subscription. Then on the management portal we create a new hosted service and set some simple properties such as name and location, which are very standard stuff whenever you create any kind of let's say if you create a email ID of yourself, you have to provide name and location, and if you are true you put it all true. But here it's a bit different. The location is not your geographical location. Instead of choosing the location, it's better to choose an affinity group. An affinity group means that all the servers, virtual machines, will be located in the area that we select as an affinity group. Once this is done, we create a certificate to ensure that only those who have this certificate are allowed to publish. This is a measure for the security. We create this certificate in Visual Studio by going to Server Explorer, then right clicking the Windows as a component tab and selecting Add Deployment Environment. Then in the tab we right click on the Windows Azure account and then clicking New. On this window, the new window, we can create a new certificate, and then in step 2 we can copy the path of the certificate to the clipboard. So we created the certificate and we know where exactly it's located. Now then we go back to the management portal and navigate to management certificate tab. Here we click the add certificate button. So once you have the subscription open, once you have the subscription for the management portal, you can log into that, navigate to the management certificates tab, and then you add certificate. Then you click the add certificate button. Here you can copy the path what we have created in the step over here, and then finish adding the certificate. Once the certificate is added in the management portal, on the right side you will see that a subscription ID is generated. Copy this subscription ID and go back to Visual Studio. Paste the ID in step 3. Give this certificate some name and click OK. Now go back to management portal and click on storage accounts and then click on new storage account. Now create a new storage account by choosing the same affinity group as chosen above. This is not required, but it's a good practice to have your storage and app virtual machines to be near to each other. At first, it seems a lot of work, but it is not. It's just one-time setup stuff. So, if we go back and summarize it again, what you have to do is you need to have a subscription. Then, once you have a subscription, you create a certificate from the Visual Studio. Then, you create a subscription ID from the management portal. Then, you use the subscription ID in the Visual Studio, and you are done. So, it's quick, isn't it? With all these steps, you are done with the settings for publishing to the cloud. Now you have your Visual Studio with all the subscription and the security settings, and now this is the fun of Azure. You work with the Visual Studio, Azure Desktop, create your application or develop your application, deploy it, publish it to the cloud just with a click. So you can see how Azure is very helpful with you. Now moving on to the next agenda point, and that is Azure administration. Cloud database administration is curtailed without Windows Azure. Cloud database administration is a perfect option for those who want to serve their customer without the hassle of patching and programming. Designed to make your life easier, SQL Azure replaces the physical server, offering convenient storage for database around the globe. This technique also ensures faster access to data and will cut down on hardware costs. Basically, SQL Azure is highly affordable. When talking about its peculiar offering, SQL Azure makes life easier. It is packed with software installation, patching, and fault tolerance. It is compatible with TSQL and old SQL Server models. Saving time, Azure helps you to concentrate on application and performing all kind of administration, building and maintaining jobs. So with this, a small introduction of Azure administration is finished, and before that we had already discussed about how we publish to the cloud. So we move on to the next agenda point, and that is Azure storage. That's, I believe, the most important one after the programming, because the data is something which is very critical for any kind of business. From the previous slides of the presentation, we found that local storage is one of the primitive storage mechanism in Windows Azure. The core features of local storages are temporary storages. Features provided by the operating system is similar to a hard drive, almost a simulation of a hard drive. It's exposed as a logical file system, and the .NET directory file IO framework used to access it, and can be used for storing cache items. So what you conclude with the local storage is you can see it as your computer's hard drive, but of course it's not there on your system. It's somewhere else. You never know. You have seen 6 data centers over 3 continents, so it can be in Asia, in Europe, or even in America. Doesn't matter to you. So you can see how easy it is, and it's very straightforward to look at these local storages. All the storing systems and all your data are protected by the Microsoft's policies and lot of firewalls and stuff, so you need not to worry about the exploitation of your data. So there's a peace of mind, so you don't need to go more detail inside the local storages, I believe so. And we go to the table storage. Windows Azure Table Storage is an example of this kind of NoSQL approach. Here you see the application and the partitions within the table, and all are on the hard drive. So despite its name, table storage doesn't support standard relation tables. Instead, it provides what's known as a key or a value store, associating a set of data with a particular key, then letting an application access that data by providing the key. Go to the blob now, to the blob storage. What a blob is. A blob and the page blob that are supported in the Azure storage. Block blobs are a quite general approach to storages, and they are the most commonly used blob type today. You could have seen a lot of database columns using the blob, where you store the entire file or a whole image. So that's all the blob. Page blobs are designed for random access, so each one is divided into some number of pages, like a book. An application is free to read and write individual pages at random in the blob. So when we go with the blob, if we have to look, let's see over here, you have to read through all this and go over here. But the advantage with the page blob is, let's break this in two, and one till here and one till here, so you don't need to go through all of this, you just need to start from here. So I think the page blobs are much better than the block blobs. Now, to use blobs, what you have to do, you have to first create a Windows Azure storage account. As part of this, you specify the Windows Azure data center that will store the object you create using this account. Wherever it lives, each blob you create belongs to some container, that is this, in your storage account. To access a blob, an application provides a URL in the form like https :: and two // then the storage account .blob.co.windows.net / the container, and then the blob name. So that's all. A storage account is a unique identifier that will be given when you create your storage account, while container and blob name are the names of the specific container and the blob within the container. So what three items you need to have the storages is the blob name, the container name, and the storage account name or the storage account ID. As I told you, and you can see from the picture also, Windows Azure has two different kinds of blobs. With the block blobs, you can store the data up to 200 gigabytes. So with the page blob, it can have a large as 1 terabyte each. So that's what I was much more into page blobs than to the block blobs, while because the page blobs have more capacity. Whether you choose block blobs or page blobs, applications can access blob data in several different ways. The options include the like directly through a RESTful REST, it's a protocol, HTTP based access protocol. Both Windows Azure application and the external application, including applications running on a premises, can use this option. You can access the blob using the Windows Azure storage client library, which provides a more developer friendly interface on top of the raw RESTful blob access protocol. Once again, both Windows Azure application and the external application can access blobs using this library. You can access the blobs using the Windows Azure drives, an option that lets a Windows Azure application treat a blob page as a local drive with an NTFS file system. To the application, the page blob looks like an ordinary Windows file system accessed using standard file I/O. In fact, reads and writes are sent to the underlying page blob that implements the Windows Azure drive. Now, we move to the next, Windows Azure queues. I divided into two parts because of the pictures, which I thought it's very interesting. The first one, from the publisher, then to queue, then to consumer. What it is, as I told, the single queue message, that is the blob. There are a lot of queues. So Windows Azure Queue Storage is a service for storing large number of messages that can be accessed from anywhere in the world via authenticating calls using HTTP or HTTPS. A single queue message can be up to 64 KB in size. A queue can contain millions of messages up to 100 terabyte total capacity limit of a storage account. So it's really a lot. 100 terabyte. It's a lot. Then you see here, there are three things you need to know about the Windows Azure queue storage. One, account, a queue, and a message. Account is access to Windows Azure storage and with a total size of 100 terabyte, which is, of course, they say it can't exceed over 100 terabyte, but I'm sure the time when you reach till 100 terabyte, they will increase it a lot, or the whole architecture will have been changed. A queue which contains a set of messages, and these all messages must be in a queue. And what a message is any format of up to 64 KB max. So you can serialize information into messages. So you see from here, then to orders, then to different messages. So you can see how the flow is going with it. So I think the queues are clear. So Till now, we have discussed a lot about the Windows Azure storage, and uh, we can summarize it in 5 points. Fault tolerance, the first one. Second, the geo replication. Third, the REST protocol and availability. The content delivery network, and the price. With the fault tolerance, what we mean is the Windows Azure blobs, tables, and queues stored on Windows Azure are replicated 3 times in the same data center for resiliency against hardware failure, no matter which storage services you used. Your data will be replicated across different fault domains to increase availability. So, that's a really great strategy. Second thing that I discussed was the geographical replication. So, Windows Azure blobs and tables are also geo-replicated between two data centers hundreds of miles apart from each other on the same continent to provide additional data durability in the case of major disaster at no additional cost. So you know the hurricanes and the earthquakes. So even if they are, you are sure that your data is secured. Then you have the REST protocol for the accessibility of the data, which gives you seamless access and virtually from anywhere, and with the 24/7 uptime. So it's anytime, anywhere, access your data virtually. You don't need to worry about where your data is. With the content delivery network, with one click, the Windows Azure Content Delivery Network dramatically boosts performance by automatically caching the content near your customers or users. And the price is really cheap. It's really cheap. Once you go to create the Azure storage account, you'll see how cheap it is. The only reason that I see you won't be interested in the Windows Azure storage platform would be if you are called Chuck Norris. Now, if you are still reading and still programming and still thinking, what does it mean by the Chuck Norris? So let's get on it with it. Windows Storage Queue is a service for storing larger number of messages that can be accessed from anywhere in the world via authenticating using HTTP and HTTPS. Okay, now going further into the presentation, we hit the agenda again. The Azure worker role. Worker roles can receive the messages they need to process in either a push or pull way. Pushing a message to a worker instance is an active approach where you're directly giving it work to do. The alternative is to have the role instances call out to some shared source to gather work to do. In a sense, pulling is the messages they need. When pulling messages in, remember that there are possibly several instances pulling in work. So you need a mechanism similar to what the Azure Queue service that provides avoidance of the conflicts between different worker roles instances that are trying to process the same work. Keep in mind the difference between roles and role instances, which are covered, although it's sometimes convenient to think of workers as a single entity. They don't run a role when they are running, but as one or more instances of that role. When you are designing and deploying your worker rules, keep this duality in mind. So, what is the duality? That is, they don't run as a role when they are running, but as one of more instances of the role. This will help reduce the number of problems in your architecture. One advantage that worker role have over web roles is that they can have a many service endpoints as they like, using almost any transport protocol and port. Web roles are limited to HTTP or HTTP secured and can have two endpoints at most. We'll use the worker roles flexibility to provide several ways to send it message. We'll cover three approaches to sending messages to worker role instances. One, the pull model, one, a push model, and a push model with a variant. So the first pull model, where each worker role instances polls a queue for work to be completed. Second one is a push model, where a producer outside Azure sends message to worker role instances. And third one is of course a push model, but where a producer inside the Azure application sends message to worker role instances. So you can see briefly all what it is here. The most common way for a worker role to receive message is through a queue. A general model is to have a while loop that never quits. That's how a loop works. That's how a queue works. This approach is so common that the standard worker role template in Visual Studio provides one for you. So you don't need to write. You don't need to write even that. The role instances tries to get a new message from the queue where it's polling on each iteration of the loop. If it gets a message, it processes the message. If it doesn't, it waits for the time, perhaps 5 seconds, and then poll the queue again. The waiting time is configurable, so you can make it 5 seconds or 1 second, or if you need a real-time monitoring or real-time storages, rendering stuff, then you can decide upon that. The core of the loop calls the business code. Once the loop has a message, it passes the message off to the code that does the work. Once that work is done, the message is deleted from the queue, and the loop polls the queue again. So you might jump into the conclusion that you could easily poll an Azure table for work instead of polling a queue. Perhaps you have a property in your table called status that defaults to new. The worker role could poll the table looking for all entities whose status property equals new. Once a list is returned, the worker could process each entity and set their status to complete. At its base, this sounds like a simple approach. Unfortunately, this approach is a red herring. It suffers from some severe drawbacks that you might not find until you are in testing or production, because they won't show up until you have multiple instances of your role running. The first problem is of concurrency. If you have multiple instances of your worker roles polling a table, they could each retrieve the same entities in their query. This would result in those entities being processed multiple times, possibly leading to status updated getting entangled. This is exactly concurrency problem the Azure Queue service was designed to avoid. The other and the more important issue is one of the recoverability and durability. You want your system to be able to recover if there is a problem processing a particular entity. Perhaps you have each worker role set the status property to the name of the instance to track that the entity is being worked on being a particular instance. When the work is completed, the instance would then set the status property to done. On the surface, this approach seems to work sense. The flaw is that when an instance fails during processing, which will happen, the entity will never be recovered and processed. It will remain flagged with instances name of the worker processing in the item. So it will never be cleared and will never be picked up by the query of the table to be processed. It will in effect be hung. The system administrator would have to go and manually resets the status property back to new. There is not a way for the entity to be recovered from a failure and reassigned to another instance. It would take a fair amount of code to overcome the issue of polling a table by multiple consumers. And in the end, you had end up having built the same thing as the Azure Queue service. The queue service is designed to play this role, and it removes the need to write all of this dirty plumbing code. The queue service provides a way for work to be distributed among multiple worker instances and to easily recover that work even if the instance gets failed. A key concept of cloud architecture is to design for failure recoverability in an application. It's to be expected that nodes go down and will be restarted and recovered, and possibly on a completely different server. Queues are the easiest way to get messages into worker role. Now, though, we'll discuss inter-role communication, which lets a worker role receive a message from outside the Azure. Web roles are built to receive traffic from outside of Azure. Their whole point in life is to receive messages from the internet, usually it's a browser, and respond with some messages like say HTML in most of the cases. The great thing is that when you have multiple web role instances, they are automatically enrolled in a load balancer. This load balancer automatically distributes. I always say distributes. So this load balancer automatically distributes the load across the different instances you have running. Worker roles can do much the same thing, but because they are not running in IaaS, which is not available on a worker role. You have to host the service yourself. The only real option is to build the service as a WCF service. Our goal is to convert a little string reversal method into a WCF service and then expose that externally so that customers can call the service. The first step is to remove the loops that polls the queues and put in some service plumbing. When you post a service in a worker role, regardless of whether it is for external or internal use, you need to declare an endpoint. How you configure this endpoint will determine whether it allows traffic from source internal or external to the application. The two type of endpoints are shown in this picture that you see. If it's configured externally, it will use the Azure load balancer and distribute service calls across all the role instances running the server, much like how the web role does this. We'll look at the internal service endpoints in this section. So we have internal endpoints and we have external endpoints. And you know the worker roles have two ways of exposing their services. The first is an input service. These are published to the load balancer and are available externally as role 0. The second is an internal service which is not behind a load balancer and is only visible to our other role instances. With this, we are done with the Azure worker role. Now, we move on to the agenda, and the next item is SQL Azure. Okay, so it's a nice diagram that you can see with a lot of tables, stored procedure, triggers, federation, user data, and the explanation of what a federation is. So first we go with the Windows Azure SQL database. Windows Azure SQL database is a cloud-based relational database service which is built on SQL Server technologies and runs in Microsoft data centers on hardware that is owned, hosted, and maintained by Microsoft. Similar to an instance of SQL Server on your premises, Windows Azure SQL database exposes a tabular data stream interface for transact SQL based database access. This allows your database application to use Windows Azure SQL database in the same way that they use SQL Server. Because Windows Azure SQL database is a service, administration in Windows Azure SQL database is slightly different. Unlike administration for an on-premise instance of SQL Server, Windows Azure SQL database abstracts the logical administration from the physical administration. You continue to administer databases, logins, users, and roles, but Microsoft administers the physical hardware such as hard drives, servers, and storages. This approach helps Microsoft Windows Azure SQL database provides a large-scale multi-tenant database service that offers enterprise-class availability, scalability, security, and self-healing. Because Microsoft handles all the physical administration, There are some differences between Windows Azure SQL database and an on-premise instance of SQL service in the terms of administration, provisioning, transact SQL support, programming model, and features. Although Windows Azure SQL database plays an active role in managing the physical resources of the database, the DBA plays a very important role in administering SQL database based database application using Windows Azure SQL database. DBAs manage schema creation, statistics management, index tuning, query optimization, and security administrations like logins, user roles, and so on. Database administration in Windows Azure SQL database differs most from SQL Server in terms of physical administration only. That's what we say with the pass also. Windows Azure SQL database automatically replicates all data to provide high availability, and it also manages load balancing, and in case of server failure the transparent failover goes on. To provide this level of physical administration, you cannot control the physical resources of Windows Azure SQL database. For example, you cannot specify the physical hard drive or file group where a database or index will reside, because the computer file system is not accessible and all data is automatically replicated. SQL Server backup and restore command are not applicable to Windows Azure SQL database. SQL database allows you to back up your database by copying it to a new database in SQL database. Although backup and restore commands are not available, you can also use SQL Server Integration Service and the SQL CMD utility to bulk copy data. If we talk about the features and types, Windows Azure SQL database does not support all the features and data type found in SQL Server. Analysis services, replication, and the service brokers are not currently provided as services on the Windows Azure platform. Because Windows Azure SQL database performs the physical administration, any statement and options that attempt to directly manipulate physical resources will be blocked, such as a resource governor, file group preferences, and some physical server DDL statements. It will not possible to set server options and SQL trace flags, or use the SQL Server Profiler or the database tuning advisor utilities. That all will be done by Microsoft itself. So you are not allowed to touch the stuffs physically or tune the physical properties of a SQL database. Windows Azure SQL database supports many SQL Server 2008 data type. It does not support data types that has been deprecated from SQL 2008. So now if we see at the federations in SQL database, that are the way to achieve the greater scalability and performance from the database tier of your application through horizontal partitioning. One or more tables within the database are split by row and portioned across multiple databases. This type of horizontal partitioning is often referred as sharding. The primary scenario in which this is useful are where you need to achieve scale, performance, or to manage capacity. SQL databases can deliver scale, performance, and additional capacity through federation, and can do so dynamically with no downtime. client applications can continue accessing data during repartitioning operations with no interruption in service. Within a federation architecture, a federation is basically what it is. A federation is a collection of database partitions that are defined by a federation distribution scheme, known as federation scheme. A federation scheme defines a federation distribution key, which determines the distribution of data to partitions with the federation. The federation distribution key must be an int, big int, unique identifier, or variable binary, which can be up to 900 bytes or something like that, and specifies a range value. There can only be one federation scheme and one federation distribution key for a federation. The diagram that we see, it illustrates the logical and physical model of a federation. Where you have user data with, let's say, sales of from customers, inventory and orders and so on, which are stored in tables, have some stored procedures, triggers to execute some automatic queries or do some loggings and stuffs like that, and then on top of that, it's all governed by the federation. What the federation is, you can see over here, it is orders with orders table and order detail table with tables, a lot of tables inside that. So that's how a federation is. You might think, what design considerations you need to have in the federations? So here it is. When designing a federation, one of the most important design decision is what value to federate on. Ideally, you want to select a key that allow you to federate data from multiple related tables, so related rows are stored together. For example, in the case of multi-tenant application, you might select the tenant ID. The row within each federated table that specify the same tenant ID value would be stored in the same federation or atomic unit. You must also consider how to insert new records in such a way that all federation members are equally utilized. Instead of storing all new records in one member, determining how to distribute new data among federation members must be handled at the application layer. Since there is a physical separation of data contained in the different federation member, and SQL database doesn't support join operations across database, your application must implement logical code which supports the joining of the data over the multiple federation members and multiple federations. For example, a query that needs to join data between two federations would need to perform separate queries against each and join the data within the application. The same holds true for aggregating data across multiple shreds within a single federation, such as obtaining a count of all rows contained within the federation. So that's all about the SQL Azure Federation. So we'll look in a nutshell. SQL Azure provides a logical SQL server, a gateway server that understands TDS protocol, looks like SQL server to TDS client. Actual data has been stored on multiple backend nodes. For the safety of the data. The logical optimization supported by the indexes, query, plans, etc., whatever we used to have in our traditional SQL stuff. The physical optimization is not supported as per the policy of SAS. No, sorry, it's not SAS. It's PAS. So, as per the policy of platform as an service, you don't need to do anything with the physical stuffs. You have to do only with the application and the data. So you can do all the things with your data, but you don't need to do anything with the physical infrastructure. All the physical infrastructure will be maintained and optimized and supported and secured by the vendor. In this case, with the Azure, it's Microsoft. Okay, going further with the SQL Azure tools, we have Windows Azure Platform Management Portal, SQL Server Management Studio, SQL CMD, same as our traditional one, Access with the MySQL one, the PCP utility, and a Power Pivot. With Windows Azure Platform Management Portal, you can manage all your Windows Azure Platform resources from a single location, including your SQL database. The management portal seamless allow for complete administration of all Windows Azure Platform resources. Streamlines administration of creation and managing SQL databases and allows for ultra efficient administration of SQL database. The new management portal is 100% Silverlight and features getting started wizards to walk you through the process of creating subscriptions, servers, and database, along with integrated help and a quick link ribbon bar. The database manager is a lightweight and easy to use database management tool for SQL database. It is designed specifically for web developers and other technology professionals seeking a straightforward solution to quick develop, deploy, and manage their data-driven application in the cloud. The project Houston provides a web-based database management tool for basic database management tasks like authoring and executing queries, designing and editing a database schema, and editing table data. Major feature in this release of the Windows Azure Platform Management Portal is a navigation pane with object search functionality, information cube with basic database uses statistics and resource links, table designer and table data editor, added view designer, added stored procedure designer, and TSQL editor. Next one is the SQL Server Management Studio. Starting with SQL Server 2008 release 2, SQL Server Management Studio can connect directly to SQL database. The minimum install to do this SQL Server Management Studio Express edition, which is free. However, any edition of SQL Server except SQL Server Express edition that includes the SQL Server Management Studio will work. Then we have SQL command with which you can connect to the SQL database, and it lets you enter transact SQL statement, system procedures, and script files at the command prompt. Then you have few SQL Server migration assistants. like SQL, like MySQL, Access. Access is SQL Server Migration Assistance (SSMA) that supports migrating your schema and data from Microsoft Access to SQL database. SSMA makes it possible to move data directly and easily from Microsoft Access databases. SSMA allows you to upsize your data from the access to the full relational database to SQL database by transitioning from the Access database to SQL database using the migration assistant with all the benefits of SQL database. Best of all, your existing Access application front ends can continue to be used with the data now residing in SQL database. Access to 2010 can connect transparently to SQL database data, opening up opportunity for Access users and technology providers to create rich experiences while leveraging the benefit of the cloud on a pay-as-you-grow. That's the elastic basis. Second one from the SQL Server Migration Assistant is MySQL, which supports migration from MySQL to SQL database. SSMA makes it possible to move data directly and easily from MySQL databases into SQL database that help you better consolidate your disparate departmental or ad hoc data into a centrally managed and highly scalable environment on SQL database. Then comes the BCP utility. The BCP utility is a command line utility that ships with Microsoft SQL Server. It bulk copies data between SQL database and a data file in a user specified format. The BCP utility that ships with SQL Server 2008 R2 is fully supported by SQL database. So you can use BCP to backup and restore your data on SQL database. You can import large number of new rows into SQL database tables or export data out of tables into data files by using the BCP utility. The BCP utility is not a migration tool. It does not extract or create any schema or format information from or in a data file or your table. This means if you use the BCP utility to back up your data, make sure to create a schema or format file somewhere else to record the schema of table you are backing up. BCP utility for data file do not include any schema or format information. So if a table or view is dropped, you don't have a format file. You may be unable to import the data. The BCP utility has several command line arguments, which you can see the documentation from Microsoft. Now, the last one, the pivot, the Power Pivot. The Power Pivot is a powerful downloadable extension of Microsoft Excel that allows you to perform business intelligence and analytics against known data sources. One excellent data source you can use is your SQL database. One big advantage of using SQL database as a data source is that it can be accessed anywhere where you have the internet connectivity, and you can store large amount of data securely and with high availability. Your Power Pivot users can run their reports on the road without having to VPN into your data center. Also, they don't have to travel with a snapshot of data, which is outdated the minutes after the snapshot. So with this we are finished with the Power Pivot. No, we proceed to agenda, and the last item we have in our agenda is the Windows Azure Diagnostics Services. Here's a diagram, a nice one, I think so, to show how the Windows Azure Diagnostic Services works. Like many programmers, when I started writing code, I used print statements for debugging. I didn't know how to use a debugger and a print statement were a crude but effective way to see what my program was doing as it ran. Later, I learned to use a real debugger and drop the print statements as a debugging tool. Fast forward to when I started writing code that runs on servers, I found that those print statements now go under the more sophisticated heading of logging and tracing. So, this is again back, which is the essential technique for any server application programmer. Even if you could attach a debugger to a production server application, which often is not possible due to security restrictions on the machine that are hosting the applications, the type of issues server applications run into are not easily revealed with traditional debuggers. Many server applications are distributed running on multiple machines, and debugging what happening on one machine is not always enough to diagnose real world problem. Moreover, server applications often run under the control of an operations staff that would not know how to use a traditional debugger and calling in a developer for every problem that is that's not of course desirable, and it's not a practical option also. Ideally, any server application and basically any web application, including those running under Windows Azure, have a logging has a logging and tracing strategy designed in from the beginning. The logging information should be robust enough to describe nearly everything that's happening within each component. However, just as those print statements I added to my first program that could produce a lot of output. So so a lot of logging. Well designed logging and tracing thus includes ways of adjusting a type of volume of logging from any component. This allows operational staff and the developer to focus on a particular misbehaving component. Furthermore, because server applications are commonly distributed applications, information must be collected and aggregated from multiple machines and get a full picture of what was going on when a particular problem occurred. So, a way to identify a transaction thread through the machines is important, allowing the aggregation after the fact. The logging available in Windows Azure is matured through the community control community technology preview, that is CTP, that we had discussed in logging and security a little bit. The ETW provides a model in which code logs to one or more trace sources, like we see over here. Here is your assembly, here is one trace source, and this is the source switch one that goes into the diagnostics monitor. Same as we have multiple assemblies goes to a sources, then you have a custom trace listener, and all the things that are logged that goes into Azure table storage. And with my custom trace listener, You listen to what you want to listen. In order to understand the process of diagnostic monitoring, we need to understand that the data to be collected is the most essential stuff for this process, and you will need to have a Azure storage instance set up and configured. This will assist the process of providing a point of collection for the data being gathered. You will be able to have transfer done on a schedule based on collection needs, and will also have an option is to transfer the information on demand. Once you have the information in hand, then you need to go and verify the diagnostics data. There are several ways to do this depending on how and where the data has been set to store. Once the diagnostic data is transferred to the store, you will transfer that information to a local path if that is the option desired, and then run local tools to evaluate and review the data collected. This can be done using a tool like Windows Azure MMC, which can be downloadable from the Microsoft site. The MMC snap-in provides a graphical view of services, diagnostics, and storages built on top of Windows Azure Service Management CMD LEDs. The MMC is a plugin based and extensible and can be used to remotely configure, download, and then view diagnostics. Another option is to use a tool that has the capability of connecting directly to the store and will assist you in reviewing the information in a more visual and graphical manner. For example, you can use the Windows Azure Diagnostics Monitor, which can be downloaded from the Microsoft's website as well. When you go with the monitoring Windows Azure, you see that the monitoring services and the applications is a normal part of the IT management process, and having tools that will assist in controlling and understanding what an environment goes through is an important part of that process. There is a need to have systems monitored both through human interaction and monitoring tools and through the use of automation to provide continuous monitoring. System Center Operation Manager has the capability of managing an environment where internal and or external SLA are essential, and it plays very important role in business and community playing. This might come very handy if you are already experienced in using System Center and having a existing deployment on premises. In Windows Azure Operational Manager with 2007 release 2, you are allowed to monitor the availability and performance of application running on Windows Azure platform. It utilizes a management pack that has intelligence and checkpoints as a part of its structure. This allows it to connect to the instrumentation information in order to remotely discover a Windows Azure application and then collect useful instrumentation information. In order for this process to take place, the following are required. You have to enable Windows Azure Diagnostics as a on the application to monitor. You have to configure diagnostic data forwarding. This will forward information from your role to a storage account. You will have to have a valid certificate in place to be able to authenticate against the Windows Azure portal. You have to create run as account needed for the monitoring template, like Windows Azure run as profile blob, Windows Azure run as profile password, Windows Azure run as profile proxy. And the profile proxy is an optional stuff you may or may not create. And finally, you need to configure discovery by running the monitoring template. What informations will be collected? Once you have configured the operational manager 2007 R2 implementation and connect and gather information, you will use the information pack to discover Windows Azure application, provide status of each role instance, collect and monitor performance information, collect and monitor Windows events, collect and monitor .NET framework trace messages from each role instance, and groom performance event and the .NET framework trace data from Windows Azure storage account, and change the number of role instances. So we can conclude that Windows Azure is no stranger to the needs IT professionals have in maintaining and monitoring solutions and applications that exist within the platform. Understanding internal needs and SLA for keeping those applications healthy and responsive is key to success of the deployments and implementation that live within it. There are several options applicable to achieve knowledge into health of the Windows Azure application and services. IT professionals can make use of tools common within on-premises deployment and also adjust and set needs based on consuming information available through Windows Azure Diagnostics. So we had gone through almost or yeah we had gone through all modules and all the agenda points that we had over here, and I believe that you have a very good feeling of the Windows Azure. Personally, I prefer it a lot because I don't need to maintain any infrastructure, and I just need to focus on the work that I am supposed to do. Just develop the application, maintain or supply the data. I don't need to maintain my data. Microsoft is doing that for me. So the scope of the IT development has been changed from a traditional, and the future will be of Azure, that I can say. So that's all about this. So I thank you very much to watch the video and hope to meet with you on some other topics. Thanks.